Creating a custom thin pool. You can create custom thin pools to have a better control over the storage. So you can create custom thin pools to have a better control over the storage, prerequisites, administrative access, display available volume groups, VGS hyphen or VG underscore name. So VGS hyphen o VG underscore name. VGS hyphen o VG underscore name list available devices LSBLK. To list all the available devices, I can use LSBLK command. And see how the devices are arranged here. The storage is arranged. LSBLK STA volume group log linear log wall linear and then wall group 200 log wall rate 0 r image underscore 0. So like this I've arranged the storage like this. So NVMe is 0 N1, NVMe is 0 N2. So in this there is LVM also, volume group. So this is part of the wall group pass device. So these two disks are free actually now. NVMe 0 N3, 0 N4. These two devices are free now. Create a LV to hold the thin pool data. Create an LV to hold the thin pool data. LV create hyphen hyphen name. Thin pool data name hyphen hyphen size is size volume group name slash device path. So create thin pool data name with the name for your thin pool data LV. Create thin pool data name with the name for your thin pool data LV. Replace size with the size for your LV. Replace size with the size for LV. Replace volume group with the name of your volume group. Replace volume group name with the name of your volume group. So create a LV that holds to hold the thin pool data. So for this I will use the device path. I will use the NVMe device this time. So for this I will have to create PV physical volumes on the NVMe device slash save slash NVMe 0 N3. So it's already part of the volume group, actually wall group pass device. So I will use the LV create command and I will specify the volume group name and device path. So I've shut down the system. I'm adding the new NVMe devices. I'm adding new NVMe devices. So manage virtual machine settings. Hard disk, I'm adding a new NVMe hard disk of size 2 GB. Create a new virtual disk of size. I'll use only 1 GB here. 1 GB. Store virtual disk as a single file. We'll add another hard disk, NVMe hard disk. Size 1 GB. Store virtual disk as a single file I'm giving. Okay. LS. So I've added NVMe 0 N5, NVMe 0 N6. So on this I will create the physical volumes. PV create /save slash NVMe 0 N5 and PV create /save slash NVMe 0 N6. So physical volume created. VG create wall group pass device 2 and add /save slash NVMe 0 N5. So volume group created. After creating the volume group, I will create the logical volume to hold the thin pool data. So LV create hyphen name thin pool data name thin pool data name. So log wall thin pool data name hyphen size. Size is 500 MIB. Says thin pool data name. Wall group name. Wall group name is /save slash wall group fast device 2 slash device path /save slash NVMe 0 N5. So logical volume log wall thin pool data name created. LV create hyphen name. LV create hyphen name log wall thin pool data name hyphen size is 500 MIB /save slash wall group pass device 2 /save slash NVMe 0 N5. So logical volume log wall thin pool data name created. So logical volume log wall thin pool data name created. Replace thin pool data name with the name for your thin pool data LV. Create a LV to hold the main thin pool data. So replace thin pool data name with the name for your thin pool data LV. Replace size with the size for LV. Replace volume group name with the name for your volume group. Create a LV to hold the thin pool metadata. So thin pool metadata. So for that I will use the pass device physical volume NVMe 0 and 6. I will add it to the volume group BG extend wall group pass device 2 /save slash NVMe 0 and 6. The volume group successfully extended. So I'll use the LV create command LV create hyphen name. Name is thin pool metadata name. Thin pool metadata name log wall thin pool metadata name log wall thin pool metadata name hyphen size. Size is I will give 300 MIB. Volume group name // wall group pass device to, and the device path slash device path is slash save slash nvme 0 n6. So LV create hyphen name log wall thin pool metadata name hyphen size is 300 MIB slash save slash wall group fast revise to slash save slash nvme 0 n6 logical volume log wall thin pool metadata name created. Combine the LVs into a thin pool. Combine the LVs into a thin pool. LV convert hyphen type thin hyphen pool thin hyphen pool metadata name volume group name slash thin pool data name pool metadata name volume group name slash thin pool data name. So thin hyphen pool type is thin pool hyphen pool metadata thin pool metadata name volume group name slash thin pool data name. So LV convert hyphen type is thin pool type is thin hyphen pool hyphen pool metadata pool metadata thin pool metadata name thin pool metadata name is this one log wall thin pool metadata name wall group name slash thin pool data name volume group name slash name slash wall group fast device 2 slash thin pool data name thin pool data name is log wall thin pool data name. So LV convert hyphen type is thin hyphen pool metadata is log wall thin pool metadata name slash save slash wall group fast device 2 slash log wall thin pool data name. So thin pool volume will with chunk 64 KB can address at most less than 15.88 TB of data. Converting wall group fast device 2 slash log wall thin pool data name and wall group fast device 2 slash log wall thin pool metadata name to thin pools data and metadata volumes with metadata wiping. This will destroy content of logical volume. Do you really want to convert wall group fast device to slash log wall thin pool data name and wall group fast device to slash log wall thin pool metadata name? Yes. Converted wall group fast device to slash log wall thin pool data name and wall group fast device to slash thin pool log wall thin pool metadata name to thin pool. So it is converted to thin pool now. Verify that the custom thin pool is created. LVS-O LV underscore name, comma, verify that the custom thin pool is created, segment underscore type, SEG underscore type. So log wall thin pool data name is a thin pool. Segment type you can see it is a thin pool. I earlier created logical wall thin pool. So now log wall thin pool data name. This is a custom thin pool. This is a custom thin pool. Custom thin pool. Additional resources VGS LVS LV create. Creating a custom VDO logical volume. With Logical Volume Manager LVM, you can create a custom LV that uses Virtual Data Optimizer video pool for data storage. So with LVM, you can create a custom LV that uses Virtual Data Optimizer pool video pool for data storage. Administrative access.